Assalamu alaikum dear students. We are discussing exercise 1.3 and today we are going to discuss the question. We have a function from closed interval -1 to 1 to or defined by f of x upon x plus 2. We have to find its inverse. Now firstly we will show that this function is bijective, that is this is 1 1 on to for 1 1. Now let x1 x2 belongs to this interval -1 1 such that f of x1 equals to f of x2. Now f of x1 is here x1 upon x1 plus 2. F of x2 is x2 upon x2 plus 2, which implies that after multiplication and cancellation x1 equals to x2. So this means that f of x1 equals to f of x2 implies that x1 equals to x2. Hence f is 1 1 function. Now for onto. Now let y belongs to this or. Suppose that f is onto, which implies that there exists x belongs to this interval -1 1 such that f of x equals to y. Here we know y is the particular element or the fixed element from this or. We will here find the value of x, whether this belongs to this interval -1 or 1 or not. Here f of x equals to y means x upon x plus 2 is y. By multiplication and cancellation x equals to 2y upon 1 minus y. 2y upon 1 minus y. Here this y is a real number, and if we put y equals to 1, x is not defined. So this means that x is real when y not equals to 1. Also here x belongs to this interval -1 1. So x is less or equals to 1 and x is greater or equals to 1, which implies that x from first is 2y upon 1 minus y is less than 1, and 2y upon 1 minus y is greater or equals to -1. By cross multiplication y is less or equals to 1 and y is greater or equals to 1, which implies that y belongs to closed interval -1 1 upon 3. So this means that if we restrict the codomain of this function, or the codomain of the function from or to -1 to 1 upon 3, that is if we consider this function from -1 to 1, that is interval this to interval -1 1 by 3, then it is a 1 1 onto function, 1 1 onto function, because here this value, this 2y upon 1 minus y is not defined when y equals to 1. So this means that it is not on to form the interval -1 to 1 to or, but if we restrict its codomain from or to interval -1 to 1 upon 3, this function becomes 1 1 onto. When this function becomes 1 1 onto, so its inverse exists. Let g be the function from codomain, that is from range -1 1 upon 3 to -1 1, that is this be the inverse. If we define this function as g of y equals to 2y upon 1 minus y, 2y upon 1 minus y, because usually the domain of this g is actually codomain of f. Image elements of f are usually denoted by y, that is why we write here variable g of y equals to 2y upon 1 minus y. Here y is variable, we can replace this y with any other variable, like g of x equals to 2x upon 1 minus x. So this is we define this function. If we compose this function with this f, that is f of g of x, it is simply by this definition of f and g, it is simply x means identity function. Similarly g of f, that is gof, is also identity function. Now when both composite functions are identity functions, which implies that g is the inverse or the required inverse of f from -1 to 1 to or, but from not to or up to -1 1 upon 3 is given by 2x upon 1 minus x, 2x upon 1 minus x. So this is the required inverse of this function f. Remember one thing here, this inverse for any function which is invertible is always unique. Like if we have two, if here we have important theorem, if f is invertible, this means that it's if the inverse of f exists, then we have to prove that this inverse is unique. Let f from a to b be invertible function, means f from a to b is 1 1 onto function. So when it is 1 1 onto its inverse exists, let's assume that it has two inverses, g1 and g2. That is, g1 is inverse from b to a and g2 is inverse from b to a. By definition, g1 of f is x, means identity function. F of g1 is identity function because g1 is inverse. Similarly, g2 of x is x and f of g2 of x is x because g2 is inverse. Now from these two equations, g1 of x equals to g2 of x equals to identity function, and f of g1 of x equals to f of g2 of x equals to x. From this we conclude here the domain as well as range of these two g1 and g2 are same. Hence, they compose over a particular function. We can say that both functions, that is g1 equals to g2, or these two are actually the same function. Hence, g1 equals to g2, because two functions are said to be equal if their domains are equal and their range sets too are also equal. So here clearly domain of g1 and g2 or b is b, while as its range is a, and they compose over a particular function, that is u of f equals to g2 of f equals to x, and f of g1 equals to f of g2 equals to x. So in this way we can say that inverse is always unique, or there exists one and only one inverse for an invertible function. So thank you.